So we're going to talk about slope now, and I would like you to sketch out, actually I'm going to turn the graph paper on, but these can be sketches. Let's draw two grids, just kind of side by side. And the very first thing I want you to have the idea of, is a big math concept, is the idea of increasing and decreasing. Now when we read this like we read a book. We look left to right, just like we read a book. Well, in English, not Hebrew. I am half Jewish, but whatever. Left to right, and we kind of look at increasing, decreasing versus that. So if I pick a point here and I picked a point here, and I connected those with a line or line segment or anything. Okay, that was close. Whatever. It's a sketch. That's going to be increasing because as x increases, y also increases. It goes from negative to positive. Actually, but just the values also increase. So one way I like to think about that is if I'm a person and I'm walking up here, I'm actually going uphill. So increasing, I'll put in parentheses, uphill. And if I was a coin, it would not really be able to roll up the hill. So decreasing is going to be the opposite. As x increases, y decreases. And let's see, let's draw a decreasing line, just kind of sketch that here. And if I was a person, I would be going downhill and falling off to my death. So we've got these ideas of increasing, decreasing, and I'm going to put a little line separator here and sort of expand this a little bit to say that when we talk about lines, when we talk about graphing lines, we have on the left side, my increasing is a positive slope. I should put that here. And my decreasing is a negative slope. So notice how when we talk about increasing and decreasing, I'm talking about x increasing and y increasing. And so we're going to put down a formal definition of slope here. And this is something you should know. A slope is the ratio of the change in y to the change in x. Mathematically, what that means is slope, which we give the letter m, is equal to the change, and that triangle is actually a delta symbol. I'm going to put that in here. It means delta. The delta symbol means subtraction. Don't worry about that. We'll use that in some other ones too. Change in y over the change in x. And some of you have gotten used to calling this rise over run. And if I'm given two ordered pairs, and I call the first one x1, y1, and call the second one x2, y2, then what I can say is as a change in y, y2 minus y1 over the respective change in x. But I could subtract them in the other order. I could go y1 minus y2 over x1 minus x2. Any of those are equal. And this all together is the definition of slope. Notice how this is not equal to y2 minus y1 over x1 minus x2, and it's not equal to the change in x over the change in y. Those are both incorrect, and they're very common mistakes that people make when they talk about slope. So, let's do some examples. We're going to keep this very simple right now at the start. We're going to find the slope of the ordered pair, -3, -2, and 5, -1. So this is the kind of a simple slope calculation. I'm going to go slope equals, and I'm going to say y2 minus y1 over x2 minus x1. And I'm going to substitute. So I'm going to have to pick which one's my first point. It doesn't matter which one we pick. I'm going to pick this one for my first one, -2 and -3. The y goes on top, the x goes on the bottom. Then I'm going to put a minus symbol. I'm going to put this very carefully here. And then I'm going to take these points and plug them in here. -1 and 5. And I'm going to put those last ones in parentheses just to make sure that I distribute negatives appropriately. Because that's actually -2 plus 1 and -3 minus 5. -2 plus 1 is -1, and -3 minus 5 is -8. And that simplifies to 1/8. That is a slope of 1/8. Graphically, that would look like this. If this was a starting point, from any point on the graph, I could go up 1 and right 8. So it'd be a very, very, very broad slope here. Kind of a very, well, almost a flat slope. Gradual, we'll say. Something like that. So this is a sketch. Let's do another example. I'm going to say, find the slope of -5/2, comma, -3, and -2, -1. If you can't tell, I'm a big fan of negatives here because this is going to make sure you guys are doing it right. So I'm going to use a different notation. We'll call this change in y over change in x. I do like the delta. Then I'm going to pull the highlighter tool and highlight the second one. The y's. Those should come first. And then I'm going to make sure I do these in order. So let's do the second one now. I'm going to do -1, then minus a -3 over. Now I'm going to do the x's, and I'm going to do them in the same order that I just did the y's. So the second one first, -2 minus a -5/2. Well, the numerator is going to become -1 plus 3, and the denominator is -2 plus 5/2. -1 plus 3 is 2, and -2 plus 5/2 is 4/2. Sorry, -4/2 plus 5/2, which is 2 over 1/2, which is 2 divided by 1/2, which is 2 times 2, or 4. And that would be the final slope for that one. All we need are 2 points to find a slope. And if I gave an equation like this, and I said to find the slope, I could do that by any 2 points. And that's how I'm going to want you to do this here. I don't want you to, right now to put it in slope-intercept form if you know what I'm talking about. Here's a point I could use. Let's do the x-intercept. The x-intercept, and this is a good review from yesterday, occurs when y equals 0. So if I substitute 0 in for y, you get 6x is equal to 14, or x is equal to 14 over 6, which simplifies to 7/3. And my ordered pair would be 7/3, comma, 0. Now for the y-intercept, this occurs when x equals 0. And so the 6x drops out, and I get -2y is equal to 14. Divide by the -2, and you get y is equal to -7. And the ordered pair is 0, comma, -7. So I can actually find a slope now because I have 2 points. So I'm going to say slope equals, let's do the first minus the second for the y's, so 0 minus a -7, over first minus the second, 7/3 minus 0. And I get positive 7 over 7/3, which is positive 7 divided by 7/3. And that's positive 7 times 3 over 7. And the 7's will cancel, just giving you 3. I'm going to go back to giving you points. Let's talk about number 4. -6, comma, 5, and 2, comma, 5. Well, what's going on here is that I have, let's do the change in y, so slope is equal to 5 minus 5 over negative 6 minus 2, which is equal to 0 over negative 8. And 0 over anything is 0. The slope is 0. But if I pick one like this, negative 2, negative 6, negative 2, 5, and I do a slope, negative 6 minus 5 over negative 2 minus a negative 2, get negative 11 over negative 2 plus 2, which is negative 11 over 0. That, my friends, is a divide by 0. And we call that undefined. So we have slope equal to 0 and slope undefined. Those are two possibilities as well. New problem type. Determine the value of k so that 7 comma k and negative 1 comma 2 has a slope of 3 over 5. Okay, this is just testing the same exact thing that we did. We want to calculate a slope with this point and this point, and I'm going to do that. I'm going to take the numerator, or take the y's. I'm going to go k minus 2 over, and then 7 minus a negative 1. And that's my slope. And if I simplify that, I'm going to get k minus 2 over, that's 7 plus 1, or 8. That's my slope. But wait a minute, that's my slope. They're both my slope, and they're both equal to each other. I now have a problem like this, and we know how to solve these. If two fractions are equal, their cross products are equal. So I'm going to do 5 times k minus 2 equals 8 times 3, or 24. 5k minus 10 equals 24. Add 10 to both sides, and I get 5k is equal to 34, or k is equal to 34 over 5. That's a problem type that you're going to see on about 4 of these problems on the homework tonight. Let's try graph 1. I want you to graph a line that passes through negative 1, 6 with a slope of negative 2 thirds. I'm just going to draw a little grid here, and we're going to sketch the point negative 1, 6. Now, negative 2 thirds is a negative slope, which means that it's downhill, like this. A positive slope is uphill, negative slope is downhill. And if I think about what this means, this is negative 2 over 3, which is also equal to 2 over negative 3. If I look at negative 2 thirds like this, it's telling me to go down 2 and right 3. Down 2 and then right 3. And I'm going to put another point. I can make it very faint. I don't need to put it so dark, but I'm doing it so you can see this. This also means up 2 and then left 3, which is the same direction. Actually, it's opposite direction, but it's the same slope. And you should be able to put a bunch of points down. I'm going to put them all very faintly because my graphing tool wants me to put a lot of points down so that I can connect my endpoints and make a nice clean line. I want you to put arrows at the end of your lines, so I'm going to make that arrow somewhat darker. And I want to make sure that your points will cross through not just 2, but every single possible crosshair that is that slope away. You don't have to put dots there, but they does need to cross through those points. That is crucial in making a line. We're going to do one more, same idea. I'm going to graph a line where it passes through 8, negative 2. And we're going to do a slope of 0. So if I go 8, negative 2, right 8, down 2. Slope of 0, well, if it's a slope of 0, that's 0 over something, which means that my change in y equals 0. My y is not changing. My x is changing, but my y is not changing. When your x is changing, when your x is changing but your y is not changing, that kind of line where the y is not changing is a line that looks like this. It's a horizontal line. I should move this more center so I can actually graph this. This is not like when I get to the edges. There we go. And that would be a line. That's a slope equal to 0. In fact, all horizontal lines have a slope equal to 0. That's enough for today.